Hello?
Yeah, we can. I keep putting you on mute so we don't get the echo, Rob.
Oh, I see you're getting an echo there, are you?
Yeah.
The problem is if you put me on mute, you won't hear what I'm saying.
No, we can hear you. You just can't hear us.
Oh, I see. Oh, I beg your pardon. Sorry about that, Ainsley. Right, that's fine.
That's right.
So as long as you have a way of interrupting me. Right, okay. So I'm gonna go on to the next slide from here. I was talking about how we think that these things are just caused by too much acetylcholine, for example, if you're chasing a ball, or a dog that is given too much activity, or dopamine if it's something like a dog which just has too much, awful word, prey drive or something like that. You know the kind of story. And the story is kind of fueled. What I did is a review of all the kind of calming supplements that were on the market at this time. This is 2 or 3 years old now. There are a lot more, but they all contain the same kind of ingredients. And as you can see on the slide here, there's what the ingredients of these calming supplements are purported to target are the same bunch of neurochemicals, neurotransmitters, etc. And of course, neurotransmitters like GABA are really, really important, and GABA is meant to be this calming thing and all this kind of stuff. Again, this is a far too simplistic model, and it simply it's not borne up, borne up by the science. So that's kind of the popular understanding of what we think we know about these things. And so what I want to do is move away from that. And yeah, so the layperson's knowledge is something like this, where they think it's just a matter of controlling one or two things, tweaking one or two things, either with a supplement or even with psychopharmaceuticals, fluoxetine or something like that. And what you're doing is targeting a system. What all these things have in common is that what they're doing is basically targeting all the receptors of all the neurotransmitters that they are designed to engage with at the same time. And the way I see this, it's equivalent of if you can want to top up your car with some oil, instead of actually undoing the oil cap and pouring the oil in where it should go, what you do is you open the oil can and you just pour it all over the engine. And so it affects everything. And this explains why we see such heterogeneous effects of drugs like antidepressants and antipsychotics and that sort of stuff, where they work really well for some people and they don't work really well at all for other people. It is a bit kind of hit and miss, and this is why, because you really don't know what you're targeting. Right, so this is just to remind you that there are lots and lots of examples in nature and in the world as a whole, actually, where we see correlations of things. And what I've done is pulled up a few completely spurious correlations here, which relate to Google searches and the particular search terms on Google, within the Google search engine, and the kind of correlations that we see. I'm not going to read this out. You can look through them at your leisure once you get the video of this. But you can see that what we're dealing with when we have dog trainers and people putting stuff out on social media, they claim there's a correlation, but in actual fact, that correlation is just a spurious one. And the classic is the serotonin and mood state and that sort of thing. It's just a lot more complicated than that, which is why I really didn't want to dive into this and start showing you studies that then don't really give you any information that you can take away and use practically. Right, okay, so this is the neuroscientist's understanding. So this is my very short introduction to neuroscience. What I've done here is boil the brain, or the connections in the brain, the little circuits in the brain, down to the simplest possible circuit I could think of. So what we have here is a connectome of 15 neurons. So the neurons are these lines, which are making between them 29 synapses. So they're synapsing between receptors of these things. This image on the right hand side here gives you an idea of a very small, tiny little bit of a rat's brain, and it just shows how many connections there are in this. There are just, God knows how many, an awful lot. only 613 neurons, but the connections within that run into the millions and millions and millions. So connecting these things together is really, really complicated. And what I did is I did a back of a fag packet calculation on this, and I managed to work out that if you had a psychoactive substance of some sort that you thought was acting on just this little synapse here, it could affect this particular circuit in over 1 million different ways, which is an absolutely staggering number. And that's simply because of the effects that the other synapses would have on this particular connection. And it just harks back to what you see in this image that boils down to a simple statement: it is very, very complicated. And you cannot kind of make very clear predictions as to what's actually going to happen. And so that's just a little graphic that gives you an idea of what we're talking about here. It's basically many, many, many of these little units, hundreds of thousands, millions of them all working together. And that is why the brain is considered really one of the most complex organs in the universe. And I could say that for human brain, dog brain, rat brain. I would even say it for something like the brain of a fly, where it's still a complete mystery how the things all connect together. We really don't even know how the stomach of a crab works, which only has a handful of neurons. It's quite a simple little nervous system that basically just grinds food up inside the crab's stomach, and we have absolutely no idea what the connectome is. It's still a complete mystery, and there have been people trying to for the last 15-20 years. So you can see that it makes you a bit pessimistic about what we can actually understand and learn moving forwards. But it's not all bad news. So this is what the scientists actually promised us. There have been, since the 1990s, a whole lot of different brain initiatives, and I've listed 4 of them here, costing gazillions and gazillions of dollars or pounds or whatever units of currency you prefer. And I'm not going to go through these because you're going to have these slides. You'll have the video anyway, and you can go through them and look them up in your own time. But I've listed them here just for your reference. And what I'd like to come to is just go through some of the highlights of what claims are being made about what's actually being learned. And this is the list. What I can tell you here is that let's just take the first one. Mental disorders are brain diseases. And basically, of all the studies that have ever been done, scientists have never been able to identify a biological cause or even a reliable biomarker for any mental disorder. And if we go on to psychopharmaceutical drugs, the second one down, work by correcting these neurotransmitter abnormalities, there is no credible evidence that actually this happens at all. So again, it's one of these things which is a superfluous or a claim that is made that's not actually substantiated by the evidence that we have. The third one, again, about drugs, have become progressively safer and more effective, i.e. more targeted. The truth is that modern psychiatric drugs are generally no more effective than they were when they're first discovered back in the 1950s. And people who have seen my lectures before know how I went on about the discovery of the monoamine theory of depression and all that kind of stuff. And it was all a serendipitous discovery. And just in case anyone who watches this has kind of mental health issues, I need to put a caveat in here that I don't speak as somebody who knows nothing about this. I have a long history of mental illness myself, which goes right back to my early childhood, which was extremely traumatic. And I've had some really serious ups and downs ever since then. I've had many different drugs. I've had many different kind of therapies. So I kind of know I have some skin in the game here, so to speak. So I'm not saying these things don't work, but I'm saying what they don't do is they don't work in the as claimed on the bottles as claimed by mainstream psychiatrists. So for goodness sake, if you're taking any kind of medication, don't for God's sake start sort of tipping it down the toilet or anything like that. If it's working for you, that's great. And I have found certain things that work for me, but it's not the science of it still really isn't terribly well understood. So the neuroimaging one, down which is 4th on my list here, There are many, many claims made about neuroimaging, and this includes, and I will include in here, lots and lots of studies that have been done on particular systems of the brain. The problem is when somebody does a study, it really needs to be replicated by other groups, and this is a huge problem in science. I won't go into the reasons for this. Some of the reasons are political, and some of the reasons are basically that people are unable to replicate the study. And what journals don't like doing is publishing research papers that don't show any results of any significance, and so they simply don't get published, and they lie in the bank on bioarchive of sort of unpublished stuff. So they remain sort of hidden in the corners. Genomics, now the most studied condition in humans in terms of genetic studies is schizophrenia. And it's really been held up as the poster child of the success of genomics. The problem is that none of the studies actually link or help predict the kinds of people that are going to develop schizophrenia at some time during their lives, usually as teenagers. Because what we see is within the genomics, it will predict that many individuals will have schizophrenia because it's, you can read them in their genes, like you can read them in the tea leaves, but they never develop it. And then on the other side of the coin, there are lots of people who never develop schizophrenia, but their genetic profile actually says they ought to be somebody who will actually develop schizophrenia in their lifetime. So the final one down here, moving forwards, very optimistic, in the hope of more money, I guess. The thing is that if you look at what's actually happening in moving forwards, one of the biggest problems is that big pharma pulled out of this market nearly 15 years ago now. They basically stopped studying any kind of psychoactive drugs at all. And the reason for that is because they were unable to see any light at the end of the tunnel in actually understanding how the brain works from all these points of view, which I've just explained to you. All these studies have been done, but it has brought these heavy-hitting people, these brilliant pharmacologists and brilliant neuroscientists, to a point where they feel they can't invest any more money in this particular branch of brain research because they've no idea how it works. And so they're just putting money into a kind of guess and hope for the best. So what many of them have now done, the big pharma companies, is move into much more lucrative drugs, like all the glycogen, like P1 receptor agonists that I'm sure you've heard of, these weight control drugs, like Wegovy, Ozempic, Mounjaro, Z-Bound, and all those sort of things. And they're making absolutely millions out of these. The big pharmaceutical company that started this off is based in Denmark, and the gross national product, the turnover of that company now is more than the turnover of the product, the national turnover of the whole of Denmark. So this one company is more richer than the whole of Denmark, where it's actually located. So it's a kind of remarkable story, and I doubt they're going to come back to psychiatry anytime soon. Okay, so that's all I'm going to say about pharmacology. That's my pedal stool bit. What I'm now going to move on to is this bee in my bonnet that I have, which is that one of the things that's been worrying me for a long time, actually, way back to the time of 2005, and I'll go into that a little bit sooner. And some of you will remember that you were probably taking qualifications and that sort of thing at that kind of time. But what kind of dawned on me is that we are very good at characterizing what well-being and happiness is in humans. There's lots and lots of talk about it, and thank goodness mental wellness and mental health has really come back into the frame in recent years, and all of that is a really good thing. But in contrast, what we're not very good at is characterizing the same things in animals. And what I mean by that is that when we look at how we use language in humans, we talk about well-being and happiness. And when we refer to welfare in humans, it usually refers to those people who are really below the standard of what living a happy life should mean. So they tend to be people who rely on the welfare state, for example. So the language is really important here. But when you look at how we talk about the welfare or well-being of animals, are they suffering? Are they okay? All the language, and this is important from the point of view of governments and institutions and getting funding for research in this area, it's completely obsessed with retaining a welfare-centric framework. And I think this does huge injustice to how we explain welfare to lay people, lay dog people, and how we go about sort of influencing how research might move forwards in moving away from an objective scientific approach to a much more subjective scientific approach. So what I'm going to do is just show you some stuff here in the hope that I can encourage you to kind of join me on this, putting this message out that we need to change the language, because by changing the language, we can start reframing how the general public as a whole and how governments and how people who basically teach this and make legislation for animal welfare start to think about this. So a good place to start is this. Way back 200 or 2,500 odd years ago, there was a guy called Aristotle, who was a brilliant scholar. He had his fingers into all sorts of pies of the day. And what he came up with is two kinds of happiness, which he referred to as hedonic happiness, which is this. And what hedonic happiness is, and this definition is really important, it is the immediate feeling of satisfaction and joy and pleasure. So what you can see down there is my Springer Spaniels charging across the moors and the highlands in Scotland, following the scent of a deer or looking for grouse in the moorland there. And what they are experiencing is hedonic happiness. This is an emotional high they're getting of being really pleased and happy about what they're doing. Now, the other kind of happiness that he described was this eudaimonic happiness. And this is a very different kind of happiness. And it's something that we, at the moment, in the human world and extrapolating into the dog world, we tend to conflate the two. We tend to think they're the same thing, but they're not. They're very, very different things. Eudaimonic happiness is basically that general feeling of satisfaction. So it's not something you can put a finger on. It's not something that I could show you an image of, because it could be anything in actual fact. But what it means is this general sense of well-being. And to put a bit more flesh on that, in the human domain, there are many, many organizations all over the world, and many, many big sort of government departments, etc., which spend a lot of their time and spend an awful lot of money studying happiness in human beings. And these are worldwide initiatives. And what I've done is give you a screen's worth there of stuff that you can go and look up on your own. And what they're always looking at here is not this hedonic happiness, but this eudaimonic happiness here, this one on the right hand side, because this is what captures the essence of what happiness actually is. And what they do is they do it with this kind of survey. I'm not going to explain this in any kind of detail, but you know the kind of stuff. You may have got this sort of thing through your letterbox. If you were to describe how well you thought your life was going now, how would you score it? Crap, somewhere in the middle of crap, or absolutely brilliant. And you'd have a number of scoring things like this. If you do that to enough people, and this has been done with millions and millions of people all over the world, then what you can do is collate all the data and you get some kind of happiness score coming up. And this is why we know that on planet Earth at the moment, the happiest people in Europe are the Finns. So it's the Scandinavian countries which score the happiest people in Western Europe. Britain, I think, comes down somewhere, I don't know, almost near the bottom of the heap. So we're not very happy people at all, particularly now, and we can probably see why. And the kinds of things they collate, if you do this over a long time period, over people's lifetimes, and we've got life data on all of this, it's all freely available online, so you can see it. What you can get to is a kind of typical curve like this, where when we are fairly young, i.e. pre-puberty, early life, for most of us, life is actually bliss. Long summer days, lovely holidays, nothing ever horrible happens. Time passes really, really slowly, and life is kind of bliss. And then we start reaching teenage years, later teenage years, and we get this sudden plummet down here. And I guess that's probably because we start realizing that we haven't got enough qualifications, or we've got to go out and get a job, or God forbid, we might have gone and got married and had a kid, and you've got to start having responsibility for that. And then it levels out a little bit once you've got over that first hurdle. You might have got a good job by then and been paid a little bit more. And then when we get to kind of mid-age, the midlife crisis, it takes another plummet. And any of us who've reached that point and gone beyond it now probably know where that was. I'm certainly of the age where my levels of happiness are going up again. So these are my kind of grayer years, I guess. And then it kind of goes off and off, on and up until you have a heart attack and you sort of depart this mortal coil. And so these seems to be a classic curve that seems to be common across all people in the world. Now, what I did after seeing that is I went to see if anything similar has actually been done in people. I could only find one study, and this is what you see on the screen. And this is a study that was done in captive primates in zoos. Now, you've got the reference down the bottom there, so you can go and look this up in your own time. But basically what it shows, and this is scored from subjective verbal report of the zookeepers who were really responsible people. They love their animals, and they were responsible for them for the entire lifespan of that particular animal. And they spent their time filling in these scores for this particular bit of research over time. And as you can see, what we get is this exact replica of this U-shaped curve. And it does make you think whether the dogs around us, when we get them as puppies, are their days long and their summer days long, and they feel that the world is great? Do they reach the point where they're grumpy teenagers and they have a grump around and things are a bit tougher for them? Then maybe when they get middle-aged, and do they reminisce back to the good old days when they were puppies and think, that didn't turn out too well, did it? And then they get to kind of old age, and maybe the old dog that drags behind the owner as they are walking in the park with its head down, maybe that dog's not unhappy. Maybe they're just reminiscing about the good old days. I don't know. Maybe they've reached that point in the curve, which is up here. Nobody's ever done any research, and it would be lovely to have that kind of data. I don't know how we collect it, but nonetheless, it would be lovely to have it. So it's a PhD in there for somebody. And what we can see is exact opposite when we look at how people, this is across Europe, are taking or being prescribed antidepressants. And what you can see is an exact opposite of the U-shaped curve we saw, which is not surprising, is it? It kind of fits the pattern that we would expect and kind of confirms it in a way. Okay. So when we look at what's being done for animals, on the other hand, and this includes not only farm animals, but it also this is also then used as the metric for measuring companion animal health and well-being. We've got the 5 freedoms. Now you know what these are really well. I suspect you've got them etched into your brain somewhere. And they'll be there forever. Now this framework was established by the Farm Animal Welfare Council back in the 1970s, early 1980s, and David Miller added the 5 precisions in 1993. We then moved on to the 5 domains, which David Miller published in 2016. So that's a long time afterwards. That's not that long ago. This is what, 10 years, guys? Yeah, it's not long ago at all. So he fleshed it out a little bit, but it's still freedom from these physical things, isn't it? All these things are about welfare. These are the standards we'd expect for a human being to live in a modern society. He kind of mentions mental state. He mentions how they feel, which is good. So we're sort of making little inroads somewhere in that direction, but it's still not good enough. And then Miller came in again 2020. So this is during the pandemic, so he was obviously busy then. And what he did is add this extra dimension, which is about how the proximity, close or far, of human beings affect the affective experience of animals. So he started using words like affect, like feeling, but again, it's still pretty wishy-washy. It's still not the kind of stuff that we have seen, or which I've shown you about humans. Now, what this is, excuse me, is a new welfare initiative that's been launched recently. I only came across it last year, in fact, from a paper that was published by Mike Mendel at Oxford. And you can go and look this up for yourself. I'm not going to explain what it is. That's the paper. And you can go and look that up yourself and have a read. And as I say, it's got famous Mike Mendel, who is now an integral part of how we all work, in actual fact. Really, really important if you went through the COPE side of things and the COPE South Africa side of things. And what I'm going to show you here is a brief video they released in 2025 to coincide with that paper. And what I want you to notice about this video, if you can hear the sound, what they're doing is basically talking about more research is needed, and the only word they mention is welfare, welfare, welfare. And all it is to me is a recapitulation of what the people who come up with legislation and design studies of how we ought to measure welfare in animals are back where they were in the 1970s, when Cork came up with their first 5 freedoms. So anyway, hopefully you'll get the sound, but I'll just let it play.
Farm animal welfare research has largely focused on reducing suffering. But does that give animals a life worth living? How can it be for farm animals to have positive welfare? LIFT, Laying the Foundations of Positive Animal Welfare, is a European research network that aims to increase the understanding of positive animal welfare in farm animals. Researchers and stakeholders are working together to define positive animal welfare, identify methods to assess it, and suggest potential indicators that can be used on farms. That's what we need to find out. Together, we need to define the key concepts of positive animal welfare. Find out what information is most important.
But how can we know if animals are having positive welfare?
So I'm going to stop that. So hopefully you get the gist of why this makes me so disappointed and depressed. It's horrible. It's going back to the same old stuff. And what is a revelation to me, and this is work I was looking at back in 2005, 2006, is that the idea that animals express feelings, emotions, much like ours, goes back a long, long way. I'm sure you're familiar with Darwin's The Expression of Emotions in Man and Animals, but nearly 100 years before Darwin wrote that book, Jeremy Bentham, who's an English lawyer and philosopher and prominent MP, one of the things he brought up in the Houses of Parliament at that time was the debate about how we treat animals and the importance of mitigating cruelty towards animals. What he said in a famous speech is, the question is not can they reason nor can they talk, but it's can they suffer. And you know, that I think is a profound question, which really ought to haunt the way that animal welfare works today. And if you're interested there, I've written quite a lot about welfare in a number of blogs on my Emotions Are Us page there. You can go and look those up at some time at your leisure. Right, okay. Way back in 2005, I bought this book. And people may remember when I was doing the COPE diploma, I had to put on an animal welfare talk in that. It didn't last very long. I think I gave it once, and it got swallowed up by all the regulation stuff. But I read this book, and it was a revelation to me. And this is John Webster. It's never been updated or republished, but it's still available on the U4 website. And what he said is a sentient animal is one whose feelings matter. So it's very much like Jeremy Bentham's sentiment. And this is worth reading to you. It's going to take a minute or so, but it's actually worth reading, because this part of the book was an absolute revelation to me. What he said is, I have set the scene by defining and defending definitions of welfare and sentience, and by outlining sets of rules for the comprehensive assessment of animal welfare. What should we measure, and what does it mean? Like all scientific reviews, this will raise important questions, reveal some fascinating observations, yet leave dozens of questions unanswered, pending, to quote the phrase on each scientist's meal ticket, considerable further research in this area is needed. However, neither the animals nor society are prepared to wait for scientists to provide perfect answers. One of the main reasons for readdressing the matter of animal welfare at this time, remember he's writing this 20 years ago, is that I believe that the first priority is not for further study, but for action now. See, he's a real warrior, this guy. We already have sufficient knowledge to create and implement comprehensive, robust protocols for assessing animal welfare and for the provision that constitutes good husbandry, establishments of scientific labs, which goes beyond farm animals, kennels, and riding establishment. So you get the kind of idea there. And just to give you a wee flavor of what he was, how he was putting this into some kind of practical application, what he did is he said that really these things need to be measured on through three kind of questions or three metrics. Is an animal living a natural life? Is an animal fit and healthy? And is an animal happy? And so he gave some examples of this, and this is sort of taken from the books and kind of some of them made up of my own. And if you look at this slide here, what you see is on the left-hand side, a couple of animals interacting on somewhere in Africa, Serengeti Plains or somewhere. And what you want to do is ask yourself, these animals are clearly living a natural life, and is this good for the lions? Is this good for the lionesses? And then you would ask yourself, how good is it for the buffalo? It's living a natural life, but is this good welfare for the buffalo? From the buffalo's point of view, probably not. But from the lion's point of view, it is, because that lion can then go on and have cubs and feed the cubs, etc. Then the image in the middle, these cows. These cows are certainly not living a natural life. I guess they are as domestic animals, but they're still entrapped in a field, and the quality of the field might not be that good. So I guess for domestic cows, but for that buffalo on the left-hand side, which is of the same kind of group of animals, almost the same species, if you like, a herbivorous grouser, the natural habitat wouldn't be classified as natural for those cows, in the same way that many people who talk about dogs consider owning a dog as unnatural and not living a natural life. And then you look at this cat over on the other side. This cat is clearly not living a natural life in terms of how a cat would live out in the wild. But cats are absolutely masters of being able to find a really nice, snug, warm, cozy part in the house and get themselves near some kind of fire or something like that, which is far, far way beyond what they actually need just to make themselves comfortable. And so what this boils down to, what I've done here is just flesh this cat living a natural life argument out a bit here, that clearly it's not natural, but clearly its need for natural behavior is far more important for its need for natural habitat in this particular case. So what the author of this book was getting at here, Webster was getting at here, is that you really cannot pin down what welfare or well-being is by simply concentrating on one metric. You need to take in a whole lot of factors depending on how that animal is at that time, at that moment. In other words, how that animal is actually feeling. So it goes beyond just this idea of hedonic happiness. It goes beyond the idea of making sure we measure eudaimonic happiness as well, i.e. this overall feeling of good well-being. And we have many, many examples of animals like this. The second question was really about fitness and healthiness. And there are many, many examples in the animal production industry of animals that are productive in terms of what they're producing, but you wouldn't question how bad their welfare is, would you? So being fit and healthy is not necessarily an indicator of good health. That's what he was getting at. And this other metric here he put in of happiness, what he put in here is this really a life worth living? And what I wanted to do is just show you those initial slides, because I wanted then to get to this bit. What this is just a Google search of dogs. I didn't put any particular search terms in. I just put in dogs and clicked the image generator, and I got all these images of dogs. Now, most people would feel comfortable that they can estimate or make a pretty good guess as to how those dogs feel. But I think we know from many studies in dogs that this is not true. Body language is not a particularly good indicator of how that dog is actually feeling. And there are studies that show this time and time again, where people can measure the obvious things like an unhappy dog growling, or an angry dog growling, or running away from you, or avoiding you. But they're much worse at assessing the more subtle changes in behavior, like ears back, ears forward, tongue out, what the animal's looking at, whites of eyes, rolling over on tummy, all the kinds of stuff. And I could show you loads and loads of studies that show us just that. So this is a really good example I like to show people. Is an animal happy? And if you look at this image here, this spaniel is clearly a happy dog. He's running around chasing a ball on the beach. This again is one of my own rescue spaniels, and I can assure you he is a happy dog. His hedonic happiness is fabulous now. But what you're seeing in that image is just hedonic happiness. And this is my point. So when you look at a dog like this, what you're seeing is hedonic happiness. You are not seeing eudaimonic happiness, which is this all-important one down here. And this is where people are going wrong. They look at their dog, they judge how the animal feels at that moment, and then they assume that a dog's hedonic happiness in the moment then conflates with that dog's overall level of happiness and satisfaction with life as a whole. And the fact is that we know the two are not linked. And I think I might have an image of that in a little bit, because what Max, my spaniel, could actually have as well is a really nasty condition like osteoarthritis, where he has a lot of pain, he can't sleep at night, he gets terrible back pain. When he's walking around not chasing a ball, he's actually limping like mad. He has difficulty getting in and out the car, and his quality of life is not particularly good at all. He only brightens up when I get a ball out and throw it on the beach. And there are lots and lots of examples of this that you will see. As people who work with competing dogs, I'll bet you see quite a lot of dogs that are very happy to run around the Hooper ring, go on canicross runs and all that kind of stuff, because they love doing it. This is hedonic happiness. But when they get home, when they get back into their vans, when they get back into their tents afterwards, you want to see them then when they're just relaxed and chilled and they're not doing things that brings them great joy in the moment. Those dogs then, or that's when you actually see perhaps a glimpse into the eudaimonic happiness of those individuals, where you see they're much more withdrawn, they're much less engaged. And so the difference between the two, this is what I'm trying to get to here. And I'm not going to go into this in any detail. A lot of what I'm going to talk about very briefly in the next couple of slides is rooted in this. It goes back to the old EMRA system, and now there's Karen's book that's out, Karen Panier's book, and Julie and Ainsley can tell you guys all about that if they haven't already, I'm sure. And what this does is basically talk us, or at least train people to look much more holistically at how an animal feels on these kind of valence charts like this. And what we then end up doing with those is talking about things like hedonic budgets and judging what one's animals feel over periods of time. And what we know is that hedonic happiness, i.e. the moment-to-moment feelings of joy and pleasure we feel in the moments, if you add all those together over time, what they do is they define what we call mood state in the kind of mirror language. Mood state is quite different from emotional state. And what mood state defines is basically eudaimonic happiness. And I think what's very, very important, or eudaimonic well-being, I should say, and happiness. And what's really important is that we kind of know this stuff, but we need to reiterate and change the language we use around it when we're teaching other people to understand the important difference between the two. So, as I said, body language is not a good and reliable indicator on its own. You're just looking at behavior. And so what I'm getting at here is that beyond and moving towards hedonic budgets and those sort of things, is that people need to be able to trust in their own intuitions, their sixth sense, if you like. I mean, I know when one of my dogs is not well. So, for example, if Max, the dog you saw running around on the beach, was charging around like a lunatic, and he went from that day, he was then a little bit off color. I couldn't quite understand why. He didn't leap out of his basket so enthusiastically. He wasn't so enthusiastic about his food. There was just something about him that I couldn't quite put a finger on, but it wasn't quite right, because we know as caregivers, as you know, we have an intimate intuitive knowledge about the pets around us. And I'm sure you guys too, who are working with your dogs all the time, you know that if you're out there in the ring or out there on the track with your canicross, you know when one of your dogs isn't quite right, don't you? You just have this intuition, this feeling that there's something not quite right, and it's really difficult to put a finger on it, and you have this niggling worry. This is what I'm getting at here. And the bottom line is that when we are challenged with these kind of complicated, I can't quite put a finger on it, is just to go back to this old psychological idea that basically there are three windows into any kind of system. The first one are the micro changes, here the yellow one, that we see as the caregiver, the person that spends most time with the animal. These are the kind of sixth senses, etc. The second one might be the trainers or the behaviorists who only see the physical side of that animal. They only see, and the veterinarians, of course, they only see the physical side of what that animal is doing in the clinic. And then there's this middle bit, which both of them see, which are the obvious behaviors at the time the animal is in the clinic, such as lameness, avoidance, you know, trying to bite, refusing treats, and this sort of thing. And the really important thing is for any kind of caregiver who's responsible for this side of this chart, is to make sure that the person responsible on this side of the chart, be that the vet, be that the trainer, be that whoever it is, the behaviorist, that they spend far more time actually listening to what the guardian has to say. And I always think of it in terms of, you know, we've got one mouth and two ears. We need to use our mouths in that proportion. If you're somebody advising and giving solutions to somebody else's animal you don't actually live with, because you cannot know what that person knows. So that's really the message there. There's a lot of work to do on this. I would explain this in much more detail, but I won't because of things of time. How am I doing for time on this, guys? Claire? Do you want me to stop here, or do you want me to just do a little bit about sleep?
No, do some more on sleep, Rob.
Okay, how long will you give me?
Half an hour?
20 minutes?
Yeah.
Yeah, good. All right, let's do some sleep. Okay. Revelation. The way we think about sleep is highly anthropocentric, and we as a species are the odd ones out. There's a lot of information you will hear on the internet. All these people who think they would know an awful lot about dogs have written an awful lot about it, have done webinars about it. And the story you hear is that somehow dogs are special and they're different, and they're biphasic and they have to have so much sleep. They're not like us. Their sleep isn't like us. All of that is complete nonsense. What we're doing is judging those people on the patterns that we have as a society now. And what I'm showing you here are 4 groups of people. This is a study that was done fairly recently. It's actually a pair of studies that was done fairly recently. The references are down here. And what it compares is basically 4 groups of people. 3 of those groups live without electricity. So 2 of those are nomadic tribes. One tribe in Tanzania here. So these are the Hadza people, and they live a bit like the Maasai. They're off-grid, they're hunter-gatherers, and they rely basically on the light they get from the circadian cycles, you know, the mornings and the evenings. And what you can see here is that they have 2 distinct sleep patterns. They go to bed sometime at night, a bit like we do, and they wake up really early in the morning and they get out with their livestock, and they have another quite substantial sleep in the afternoon, a bit like having a siesta actually. So they're kind of biphasic as a group of people. The second group down here are us. These are our ancestors. These are the pre-industrial people who lived before the Industrial Revolution, before electricity was invented, and we may have had candlelight. And in those days, they used to have actually 2 sleeps. It was normal. If you talk to somebody, if you got in the time machine and went back a couple of hundred years, and you asked them how sleep was, they'd tell you they have 2 sleeps called first sleep and second sleep. So what they had is an early sleep. They went to bed quite early. They woke up and, I don't know, drank coffee and did stuff and maybe went out and checked on the animals. And then they had another big sleep in the early hours of the morning there. So they were kind of biphasic in their sleep cycles. Then number C down here, this is post-industrial. This is us today. So this is us since the Industrial Revolution, where it was really old Edison and his invention of the light bulb. Edison was a brilliant salesman. He probably wanted people to buy more of his light bulbs, and so what he offered was light 24 hours a day, 7 days a week, 365 days of the year. So our Western electric culture now has got used to just having this one big sleep here, this monophasic sleep, and then we spend all the rest of this time awake. And so we're the odd ones out here in terms of species. And if you look at across the animal kingdom where sleep studies have been done and this sort of stuff has been done, there's really no other animal that just sleeps like this. It's just us. And this final group down here, this D group, these are the Malagasy tribe in Madagascar, another group of hunter-gatherers. And look how many sleeps they have. They've got loads of them. And this is a kind of bifurcated nocturnal type sleep where they've got sleep all through the day. I'd love to be able to sleep like that. Can you imagine? Absolute luxury. So the point I'm getting to here is that we are the odd ones out, and the rest of the animal kingdom basically can teach us a lesson about how we ought to be sleeping. So we oughtn't to be lecturing on how we think dogs should sleep when we sleep so badly ourselves. Okay, and if you want to laugh, go and have a look at this company here. This is published by a mattress company, obviously wanting to sell special sleep mattresses. And if you just have a look at all these different kinds of sleeps they propose humans have, and if you go and look up on your favorite internet browser what Uberman sleep is, which is basically these 2-hour stretches, which gives you about 20-minute naps throughout the day. When we start looking at actually how sleep cycles work, it's a complete anathema. And these, anyone who actually does this must have gone completely lunatic or be dead from lack of sleep and a heart attack or something. But anyway, this is kind of one of the myths about what sleep is and how it actually works. So a little bit of sleep physiology. I put this slide in just so you can see what sleep is actually for. Sleep is by far something, it is certainly not something where we're actually resting and nothing's going on. It appears there's nothing going on, but in actual fact, there's an awful lot going on. And basically, it's a time for a lot of internal repair and regeneration and that kind of stuff, not only in the brain, but also in the rest of the body. Things like proteins can't really be made efficiently except when we're asleep. And that's not just the brain, that's all over the body. So we kind of rely on these cycles of good sleep and rest in order for tissue repair and those sort of things to get done. And a fairly recent discovery just a few years ago was this glymphatic, this drainage system, which is the equivalent to the brain's equivalent of a lymphatic system in the rest of the body. And this was a kind of new discovery, and it's a phase of sleep which takes place only in slow wave sleep, where literally the brain goes through these waves, the very slow moving waves, and squeezes and oozes all this rubbish out of the brain, which can then be flushed away through the poo and through the urine. So important stuff. The only thing I'm going to concentrate on here is the pattern of sleep cycles itself, and what the sleep cycle is for a human, and for the best to optimize human mental health, and also for dogs to optimize the ability of dogs to learn and their mental health as well. So that's the kind of focus of the rest of this session. So this is basically what a sleep cycle is, what sleep comprises. And what you see on the left hand side is the language of sleep. And basically what you see is there are 5 phases of sleep, or 5 stages, broken up into periods of non-REM sleep, which I've labeled in blue, and REM sleep, which is the rapid eye movement sleep that you've heard of, which I've labeled in green. And then of course there's W, which is our awake state. So that's the kind of 5 stages. And the way these stages are measured scientifically is they're measured by the amplitude of the waves, the electronic waves, the EEG patterns of waves they produce on an oscilloscope screen. So the longer the wave is stretched out, the slower the sleep. As you can see here, you can see the individual waves. Up here you can't. This is awake. And if you have a look at stage 1 sleep, if you have a look at awake sleep here, and you have a look at REM sleep right down the bottom here, they're very, very similar. So REM sleep is kind of close to actually being awake. It's fast alpha waves. And the reason those waves are fast is because what you're doing is you're consolidating memory and that kind of stuff. Now, when people look at a chart like this, they think what they're looking at is that these patterns are occurring simultaneously in the brain, i.e. they're happening all at once, and you can measure them all at once. You can't. You can only get one lot of pattern in sleep at a time. So if you put all these things in series into a long string right away across the room, that's more how they actually happen in real life in the brain. It's just put into a chart like this, so you can see them all graphically, but it does confuse a lot of people. That what you're looking at is something a bit like an ECG. You can take lots of different images of an ECG that are occurring simultaneously in the heart, but that's not what's happening in the brain here. These happen in stages, one after another. And just remember that because REM sleep is down the bottom, that doesn't mean it's the deepest kind of sleep. Stage 3 and 4, N3 and 4 are the deepest types of sleep, and then REM is down here at the bottom, suggesting on the chart that it's even deeper. It's not. REM sleep is up here, but it's just this way this graph is drawn, and this is traditionally how it's done. So you have the REM sleep, stage 1, which is that sleep which is you're kind of between falling asleep and waking up, and you'll all be really familiar with this. When you go to bed, you shut your eyes, you start drifting off, and then you keep waking up again, don't you? And you might go through several stages of that, and when you get to actual sleep, you leap into this stage, which is stage 2. These things here are sleep spindles, and I'll talk about that in a bit more length in a second. So hopefully that all makes sense. That's what this graph means. A complete sleep cycle, i.e. all 5 stages, which all animals that have ever been studied go through in a very particular important sequence. In humans, that cycle lasts about 90 minutes, about an hour and a half long. And so you have, if you're sleeping like an Uberman for 20 minutes, you're never going to have enough time to actually get an hour and a half's worth of the sleep cycle in. So you will never have a proper night's sleep, and you'll be so sleep deprived, you'll basically die, I suspect. Anyway, this is what a sleep cycle looks like. And this diagram I'm showing you here is called a hypnogram. Hypnosis as in, well, hypnosis. So what I'm showing you here are these 5 stages. So there's wake, there's REM, there's non-REM 1, non-REM 2, non-REM 3. So now you can see this chart is showing the depth of sleep. So wake is right at the top. And as you fall into deeper sleep, you go to the bottom of this chart. So think of this a bit like a swimming pool. So what happens in sleep? This is real time. This is one 90-minute cycle in a human being. So the first part of the night, what happens when you first go to bed, providing you haven't got a lot of awful problems on your mind and you're anxious and worried about something, in which case this part goes on a long time, which is a really bad thing because it then doesn't leave enough room for this lot to happen. So what happens on a normal night's sleep is that you go through several cycles of this, falling just into N1. Maybe you bypass REM completely. So this is time is along here. So you can see these lines are bypassing REM. You go from N1 to wake, from N1 to wake, and these times where you keep waking up and then you nod off again. And then eventually, depending on how quickly you sleep, I go through this phase really, really quickly. When as soon as my head hits the pillow, I'm kind of down here in REM 1 and going into REM 2. Other people take much longer. When I'm worried about something and I've got something important the next day, I take longer in this phase, and then I don't go into N1 proper till a bit later. But that's what that is. But eventually we go into N1, and then we fall into N2, which is the next stage. It just means it's a little deeper stage. It's more difficult to wake you up. You then go through stages where you fall into N3, which is this really slow wave sleep. This is the garbage clearance sleep. Lots of important things happen, and it fluctuates up and down for a while, and you go through this for several minutes, time scale down there. You then go into N3 proper. This is garbage clearance time down here. This is really, really important. Metabolism, building new synapses, or at least not building new memory synapses, but repair, building new proteins, etc. You then come out of this phase, which has lasted about 45 minutes, ideally, and then you go back into N2, and then you go back into N3, slow wave, back into N2. Then suddenly, at some point, you jump back from N2 to to REM. And I think I've got this on another slide. Yeah, there we are. You then make this leap from N2 up back into REM, and that's this stage here, this N2 transit to REM. This is a really important phase because what it does is that it precedes, predictably, in all animals, when you start consolidating memories. It's this stage here which is so important. And then what happens that after this stage here, you're in REM, and then you go back to almost being awake, and then the cycle repeats itself. So this whole thing takes 90 minutes. You go through all these phases, unless you've got disrupted sleep, fragmented sleep, in which case some of these phases are missed out and the timing isn't right. So you have bad sleep, you're tired, you're irritable, you're pessimistic. But this is what an ideal cycle looks like in an average human being. This is a human cycle. This is what a dog cycle looks. And this is from a lovely study that was done by Richter et al. 2021, so 3 or 4 years ago. And I'm not going to go through this in any detail, but what this study went out to characterize is how you define the stages of sleep in a cohort of dogs. It was quite a small study, but it was a brilliant study all the same. And what they've done is they've identified the same group of phases, N1, N2, N3, REM, etc., and wake, and they've divvied it up into cycles from the dogs they measured. You can see the cycles are quite variable, but on average, they're shorter than they are in people, about half the time. Some cycles are shorter than that, some are more, but all those stages matter. And this is really, really important for us, well, for all pet owners, in fact. Anyone who trains animals, anyone who wants to compete with animals like you guys, you're trying to help your animals learn to be better and quicker at what they're doing, because these are motor skills that are important to learn. You're basically athletes. You're people who have to learn a lot of new motor skills, like any kind of sport like that. All these stages are absolutely critical for learning. And I'm going to give you a little bit of science about learning. The key point is that we learn obviously all through our lives. This time is really, really important. This area of REM in young human beings represents the area where we get this N2 to REM transition, and when memory consolidation occurs. And you can see that as humans grow older, babies, toddlers, annoying little brats, grumpy teenagers, older people, the amount of REM sleep you actually need drops off, and this is inevitable. So you can imagine in your minds where you are on this chart. N2 kind of stays roughly the same. It's more of it here when you're younger, drops off. Shortwave sleep, garbage clearance, repair is pretty stable, but when you start getting older, and however old you are, here's years, your shortwave sleep gets less. I don't feel mine gets less personally, because I seem to spend a lot of, I go to sleep really, really quickly and I sleep really well, except these days I have to get up for a flipping wee more times in night because my bladder won't kind of hold it and it always wakes me up. And that's a pain in the butt, but there you go. You can't have everything, can you? Study in dogs shows much the same thing. So I'm showing you a few highlights here. This is from the Richter 2021 study again. N1 builds up, time gets longer and longer, which is same as it does in humans. N2, 3, they have a lot of this, which again is really important for this transition. It's much higher when you're a young dog. The scale here is months, 2 years, 4 years, sorry, 2 months, that's 8 weeks when you get a puppy. 4 months here, so 24, whatever it is in weeks, etc., etc. There's 6 months. Adolescence here, so we get the same kind of slope, and here we get the REM sleep. So it's these two that you look at for how important learning and memory is these young animals. They need this part of their sleep when they're young to learn all the basics of being a good puppy, a good citizen, etc., a stable, happy, healthy dog. And then of course this carries on much like it does in humans. And I guess the amount of N3 dogs get mirrors people. So when we have older dogs, they're having less garbage clearance and that sort of thing, just like we are. Although these are still quite young dogs, you can see how this line would fall off if they carried on studying these dogs over their lifetime, and that study has not been done yet. So this is how sleep, how memory works, how learning works. If we go back to this chart here, what I'm showing you here, I'm going back to this thing which I identified as a sleep spindle. This sleep spindle is unique to the time when we are consolidating memory, and these bursts of energy that only last a matter of fractions of seconds usually, only happen in this phase of sleep, this N2 to REM phase, and that's when the consolidation takes place. If we look at what it is in a bit more detail, magnified up again, it's in two parts. There's a sleep spindle, which is this bit here, and then there's this thing called the K complex, which is another part of this. What the sleep spindle does is it has to overcome a rather strange anomaly in the way that memorizing things evolved. So if you think about the very earliest organisms, single cell organisms, they didn't have to learn very much because they didn't live very long. They don't have many predators, and so what they had to do is just get through their day. When we got much more complicated animals, and if we just talk about vertebrates, so we talk about reptiles, talk about mammals, they have much more complicated brains. They have many more challenges and decisions to make during life. They have to be vigilant to make sure that they're not eaten by other animals or beaten up. They have to remain vigilant so they can go and forage for themselves. And vigilance is basically what we call attention to signals coming in from the outside world. Attention in the brain is managed largely by the noradrenaline system. So we're talking about the locus coeruleus, which is where all the noradrenaline in the brain is manufactured. In order for consolidation or memory to happen, to work, what the brain has to do is shut down the noradrenaline system, so it shuts down the sensory system. So when you are consolidating memory, your brain and your sensory systems, your hearing, your vision, your touch, all of that stuff is completely shut down. It doesn't work anymore. This is only for a few seconds, remember, it's not for a long time. And during that little time window, and there are lots of these during the sleep cycle, your brain is then really busy making new synapses, deleting old synapses. So if you're teaching an animal a task, what you're doing is updating the bit of task they learned earlier in the day or the day before. So a typical maneuver around a Hooper's ring, or some kind of technique you're using when you're doing your canicross, or whatever it is you happen to be doing, a motor skill of some sort. what happens is the only way the dog remembers that and refines it is through these periods where we've got this shutdown of the noradrenaline system. What the K complex does, it's a kind of backup system, and what it does is just during the course of a sleep spindle, it opens within that few seconds of a sleep spindle, it opens up little periods where it turns the locus coeruleus back on again, just to make sure that the animal's not in any danger. So it's really quite difficult to imagine how this all happens in such a short time window, but this is exactly what happens, and this is what these things are for. Sleep is an amazing thing, and I think we have to treasure the fact that we know something a little bit about how it works when we're trying to train dogs to do something and help them remember better. If you think about this as a kind of infographic, if you like, I hope it helps you realize that when you're training your dog yourself, and when you are teaching other people to do the same, if you use these kind of images, it'll help people understand why this is so important. And what I've done is put a couple of graphics in here, which shows the difference between a dog which is learning something really basic, like give a paw or something, where on day one, they're pretty bad at it. And then as their learning and understanding builds up and their memory builds up, what they then get to is a point where that task has been learned completely, as shown graphically there. In a dog that's had poor sleep and they're learning the same task over 4 days, you can see what the consequences of not actually getting a good night's sleep has on what they learn in the end. Now, you're going to see hundreds of dogs like this. I suspect if you're a behaviorist or you're a trainer or you work with dogs in any capacity, you're going to see dogs that have tried to learn something. They have to learn loads and loads of stuff, right? And there are loads and loads of stuff which they really don't learn well, and often we call those behavior problems, and then we end up having to go in and try and fix them and teach the animals to relearn. The reasons those things arise is because of this, probably. They've mislearned something and they've never been able to go back and reprocess it and relearn it and change those synapses round so they look more like this. That basically is what learning is. And I think if you show it to the people you work with in a graphic like this, it makes it much more understandable why this is so important. Okay, so that's all I'm going to say about this. I'll spend just a couple of minutes going through the rest of these slides, which is all about sleep hygiene. Sleep hygiene basically is our own mental health well-being, taking care of our own mental health well-being, and at the same time taking care of the well-being and mental health of the dogs around us. Because the way I see it, we're so connected as dyads, as human and animal, that our mental health depends on the animal's mental health, and vice versa. The animal's mental health depends a lot on us. And not obeying that rule, i.e., it's a two-way street, I think is what we know is the causal factor in so many broken down relationships between dogs and their owners, and of course behavioural problems and relinquishments to kennels. So this is just a study that shows the importance of light. So this really is a message to those of you who maybe are affected by the crappy winters we have and the lack of light and seasonal affective disorders and those sort of things during winter, winter blues. This is a study that was done on those kind of people and people with major depression. And the highlight of this study was that it compared placebo, fluoxetine for treating these depressed people, light therapy, and the combination of the two. And the bottom line here is that when these individuals expose themselves to light, i.e. very, very bright blue special medical lights, which basically simulate sunshine, when they had light therapy, the light therapy actually teamed up with the fluoxetine, and even on its own, which is that grey graph here, it was better than the fluoxetine. But when it was combined fluoxetine, it worked much, much better. So if you're on any kind of medication for particularly things like depression or anything like that, have a think about how whether you're actually worse during the winter when everything's kind of grey and that kind of stuff, and think about whether actually using light as something that will actually help you feel better and help you manage your symptoms much better is something to seriously that you should think about. And even if you're not on any kind of medication and you find these long dark days really quite horrible and difficult and you find it difficult to motivate yourself, think about actually using a light box of some sort. You can look them up on the internet. They're ones that have an extra strong bright light. They're not particularly cheap. You can't sit there with a light bulb in your house, go and buy the strongest light bulb from B&Q and think that's going to work, because it won't. You need specialized light bulbs that simulate a very particular frequency of blue light, and you can look this up online. There's plenty of information on it out there. And what you do is you expose yourself to that for 30 minutes or so first thing in the morning, and you'll find that will make a big difference if you're somebody who's vulnerable to these kind of dark mornings. And again, this is in the evenings. You need to do the opposite. So we need to prepare ourselves before going to bed. So avoid using social media, avoid bright lights in areas like the kitchen, bathroom, and that kind of stuff. Try and use the lighting in your house, which is much more towards the kind of yellowy reddy part of the spectrum, and you'll be able to see that from the lux, and also the color of the light on the light bulbs. As I say, it's really difficult to light a room, or at least light up a room bright enough to simulate the day. But these kind of light areas where we have these really bright fluorescent lights and these modern LED lights is not a good thing. You can have them on in the mornings, turn them all on in the mornings by all means, but try not to use them so much at night, and certainly stop using kind of social media so much before going off to bed. And your sleep behaviors affect the sleep behaviors of your dogs as well. And we have no research on this about how they're affected by morning daylight and the color of light in the evenings, because the research has never been done. But there is a little bit of research on mice models, and those models tell us that animals have the same kind of problems, or they are affected by different light levels in the same way that we are. A couple of studies here, which I'm not going to go to in any detail because we're running short of time, but the references are down here if you want to look them up. This basically is the effect of tiredness on how optimistic or pessimistic we feel. And the bottom line here, and this is a similar study done with dogs in a research facility. And what both of these studies show is that the environment that we live in affects our sleep, and it therefore affects how whether our sleep is disrupted, and this therefore affects our optimism or pessimism towards life as a whole. And as I say, I haven't got time to go into this now, but you can look those studies up, and there are quite a few of them out there on the internet. What you eat at night, this is the only image I'm going to show you here. This does affect some people more than others, but to put a big load on your gastrointestinal tract at night is not the idea. Spread it out during the day. And this is something I've learned as I get older. I'm much less tolerant to binging at night like I used to do when I used to work really, really hard, or harder, and not working from home, and you then kind of snack during the day. So it's something to kind of think about. So if you're a youngster, a spring chicken, when as you start to get a bit older, you might start to have to spread things out, your calories out a little bit more during the course of the day. Align with your chronotype. There are certain kinds of people who are doves and larks, i.e. people who like to get up really early, people who like to get up really late. Again, we have, and go to bed really late. Again, we have no information on animals on this. This is a luxury for us, really, I guess, for human beings, because we know that we can interrupt our sleep with alarms, etc. We have a lot of artificial light about us, but no studies have ever been done in any animals I know of that show the same kind of thing. But it is important that you need to align yourself with what your sleep patterns are. So if you're somebody who likes to get up in the morning, try and keep that routine. If you're somebody that likes to go to bed later, that's fine. Bear in mind, it's all affected by the kind of light that you surround yourself with. A bright sunny morning in summer is about 10,000 lux, which is a way of measuring blue light. Blue light is the important one for mornings, not yellow light. I know it looks yellow, but in actual fact, the light is blue of a very certain particular wavelength. You can see down there. And the reason the sky looks blue is not because it's blue. It's because what you see is the light in the sky above you, away from the sun, and that light is blue, and so you actually perceive it as blue light. So that's why it's blue light technically, but I know it doesn't look blue to you. It looks yellow, but there you go. And the other kind of light, which is evening light, and the reason evening light is this kind of much more diffuse, higher wavelength light, is because it's having to travel further, because the sun is now at the edge of the Earth, and it's got a lot of atmospheric pollution and all that kind of thing to go through, so it tends to change color, and you get much higher wavelength colors. So that's what that is. Lovely study published a couple of weeks ago, actually, or at least a couple of weeks ago. You can go and look up down here. It's open access, and this was targeted at a cohort of women, and these were people who had real problems. They had chronic pain, and they had real problems on Monday mornings. And what it shows is that the way your sleep pattern is disrupted between weekends and weekdays. So again, I go back to this idea of our sleep patterns being dictated by culture, not by our natural circadian rhythms. So we tend to maybe oversleep a little bit at weekends if you have a 9-to-5 job, and then you have to get up and go back to work early Monday mornings and get back into that routine. These individuals had much more problem with their perceived pain on Monday mornings than they did during other days of the week. And this was linked entirely to the fact that they had this kind of lie-in over the weekend, so their sleep pattern was changed, and then they had this disruption when they had to then wake up to that ruddy alarm clock again on the Monday morning. And that little thing that you think is quite unimportant has profound effects on your mental health, and it has a similar effect in dogs as well, which I shall show you in this study here, which I'm not going to go to in any detail now, but again, which was published over a decade ago. And there are lots and lots of studies on this, which is the effect of mental health and sleep of daylight saving time. So this whole idea of putting our clocks forward in summer and back in winter. I've shown you that slide already. This is the study that was done in dogs. This is 2025. So again, it's a recent study. Just a few months ago, this was published. And what it showed is two cohorts of dog. One cohort was working dogs, i.e. these were sled dogs. And the sled handlers, obviously, they obeyed their full back time, their daylight saving time on the Sunday, the day of the clocks going back. They didn't stay in bed for an hour. They got up at the same time. And of course, their dogs then had to get up at the same time as well. And they were compared with a similar cohort of dogs, which were basically just pet dogs. And so their owners basically had their lie-in on the Sunday. So they had that extra hour in bed on the Sunday. And the bottom line of this study is that the working dogs whose owners basically rigidly got up at the same time and didn't have their hours lie-in because they needed to go and work their dogs suffered in the same way they did from losing that hour's sleep in their performance. And I think this is a wake-up call. If you're somebody who has working dogs, you're working your dogs, and you have the clocks go forward in the spring and back in the autumn, but you ignore that hour saved or that hour lost, and you get up at the old time, i.e. Saturday's time on the Sunday, that may have an effect on your dog's performance. Because if you go and wake them up when they're not expecting to be woken up at the time pattern they've got used to, the sleep time pattern they've got used to, that may have a deleterious effect, a negative effect on their performance on that day. And with this cohort of dogs, it actually affected them for several days afterwards. Actually shown an effect in dogs. So particularly for you guys who are competing people, bear in mind that this may happen on a competition day for you. So you need to kind of build this into your thinking about how you work with those dogs, and also yourself. If you can have that extra hour in, or just stay in bed for an extra hour when the clocks go forward, which is really annoying, you lose that hour. Don't do it. Don't do it. Don't lose that summer hour. Just stay in bed, have the extra sleep, and then chill. And you not waking the dog That's what that sleep tells us. I've talked about the importance of memory already. There are a couple of studies in here which simply show in both humans and dogs, if you have good sleep, you will learn better. And that's what this study says here, tells us here, which is 2023, only a couple of years ago, and it's open access. You will learn better as a dog learning a new task, a complex task that may last over a few days, if you have good night's sleep between, if you break that task up into smaller parts and the dog has a really, really good night's sleep between the first stage of a task, the second, etc., the dog has much better retention. And this was a lovely study that also compared it with the dog going for a walk after it learned, the dog having to learn something else after a particular learning task, a dog playing after a learning task, and then a dog actually just being allowed to go and take a kip and have a sleep and then go back the next day. And this study is a lovely study that shows exactly that happening. So what I'm going to leave you with is this slide here. Sorry, I've run over a bit. We did start late. Is something to think about, that however calm they look when they're fast asleep, the brain is doing an awful lot. And this is a lovely slide that I nicked off of X, formerly Twitter, of the fluctuations in all the different, or a number of different hormones during the hours of sleep, 6 a.m. Through to 5 a.m. the next 24-hour cycle. And you can see how they're all over the place here. You'll find melatonin in here, cortisol, growth hormone, testosterone, blah, blah, blah. It's all in there. And the patterns seem to be largely the same for dogs, except if you want to do a bit of geeky homework on your own, if you have a look at cortisol level for dogs, corticosteroid levels in dogs, they tend not to get the same fluctuations we do. In the morning, we get really high cortisol level with high blood pressure, which gives us heart attacks, which is why Monday mornings are the time to have a heart attack. If you're a middle-aged man who smokes and drinks and eats too much, your heart attack is going to be on a Monday morning between about 6 and 12 in the morning. Because that's when you're most stressed after the effect of the weekend going back on Monday, and that's you're going to have high cortisol levels, high blood pressure, and you're basically game for a stroke and a heart attack. Doesn't happen in dogs for some reason, no idea why, but they don't get that same rise in cortisol. And there are reasons for that, which I won't go into, which is really interesting, and maybe that we can talk about that at another time. So that's me done, guys. I will stop my PowerPoint and I will stop sharing my screen, which I should be back. Good. Was that all right?
Robert? Yes, you are. Wow.
Did that? Well, hopefully it came through all right.
Wow.
And it wasn't jittery.
I think people are fairly mind blown.
Well,
what you don't know,
a bit what?
What you don't know is we've actually got 3 members here also from Birmingham Dogs Home.
Oh, brilliant.
And so I've got 4 Birmingham Dogs Home volunteers coming to help me today, and they're hoping to take everything they've learned back home to the rescue dogs there to help them get new homes. And I know that.
Brilliant. Well, I'm happy to come and, if it helps you guys, I'm happy to come and talk to you, or at least I can do it online like this, because I live in the Northwest Highlands of Scotland.
I will talk. I've got one of the centre managers. I've got the Wolverhampton branch centre manager here. So we'll try and get that arranged, because
do. I mean, I'm
Birmingham Dogs Home
rescue,
is an amazing place.
Springer Rescue Scotland. I'm in rescue. I'm a trustee for a rescue.
Yeah,
So I'm
know.
very happy to help.
That would mean a lot, because I know that the rescue, Birmingham Dogs Home is an amazing rescue, and they do a lot of work to try and build the dogs' trainability and to give them enough rest as well. So this, I know, has been huge. So thank you so much for your time, Robert.
No, you're really welcome, Claire. Lovely to talk to you, and lovely to see some familiar faces and lots of unfamiliar ones as well.
Thanks, Rob. Thanks, Robert.
You're welcome. Have you got Lisa there as well?
Yeah, Lisa's in the corner. She's been,
oh, hi, Lisa. Just I know she's going to come and talk to you. Yeah, she's going to give you an awesome talk about I can't remember what it was.
Lisa's talked about pain and
microbiome and all that kind of stuff. Yeah, I remember. Yeah.
And she talked about sleep as well, Rob. So you did a nice little dovetail and you didn't realise.
Oh, I see. All right.
Cool.
Okay, look, thanks guys. I'll let you get on. Sorry for running over a bit, but hopefully all
Don't
that
worry, it's
worked.
brilliant. Thank you,
all right,
Robert.
Claire, take care. Thanks for the invite.
Really good
Bye.
counselling. Bye.
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 Wow.
Not a thing, is it?
Sorry about the quality of the presentation, but the content was blooming incredible, yeah?